first problem, or the first type of problem on the exam, will involve colligative properties. So there are 4 colligative properties. Can anyone name them? What happens if you put a solute in a solvent? One of the first things that happen is what? We'll get a new boiling point. Will it go higher or lower? Boiling point? Higher. The boiling point will be higher because you have more solute-solvent interactions. Okay, what else will happen? The freezing point decreases. What else will happen? What will happen to the vapor pressure? That's this problem here. The vapor pressure will go down, okay, because you have to overcome more IMF to get to a vapor, hence less vapor pressure. And then there's also an osmotic pressure. So for those of you that saw Monday's lecture, we went over a problem in that video about osmotic pressure. Right, so let's go over a computation problem here. All right, so we're making a solution. Okay, what are the 2 parts of a solution? Solute and solvent. Right, very good. Solute and solvent. So it's asking to calculate the new vapor pressure on a solution when 10 grams of sucrose is poured into 200 milliliters of water, and we are at 25 degrees C. All right, and it's asking to calculate the new vapor pressure. So I'll give this on the test. So this is the equation for the new vapor pressure. And first thing, when you see this problem, you have to identify the solute and solvent. So what do you guys think the solute is? Very good. The solute is going to be sucrose. And what will be the solvent? Okay, like 99% of the time the solvent is going to be water. So So here's the new vapor pressure of the solution. The vapor pressure of water by itself is 23.76 millimeters of mercury. Okay, so that's going to be the vapor pressure of the solvent alone. But now we added sucrose, okay? And now we need to know what is the new vapor pressure. It's going to be lower than 23.76. All right, so this X here is mole fraction, okay? And it says mole fraction of solvent, which I think you said, Sam, is water. So what goes in the numerator here for the mole fraction? Okay, since it's mole fraction of the solvent goes in the numerator. And what goes in the denominator? Any type of fraction. What goes in the denominator? What goes? The total. So what's the total? Solute and solvent. Very good. If this were a mole fraction of the solute, you'd do moles of solute in the numerator. Since the equation is the mole fraction of the solvent, you're going to put solvent in the numerator. So we will calculate the moles of the solvent, which is water. Okay, but you have 200 mLs of water. How will we convert it to moles? Okay, we have a back of the hand measurement for the density. It's about 1 gram per mil. So we'll use that to calculate the moles of our solvent water. Okay, so we have 200 ml. Okay, this is the density of water, is 1 gram per mil. Okay, and then we have 1 mole of water is about 18 or so grams, because hydrogen is about 1.01. Okay, but there's 2 elements of hydrogen, and oxygen is 16.01, and there's 1 of that. So this is roughly from the periodic table. So about 18.03. grams of water. And we use the density of water to get that calculation. All right, so the mils cancel, the grams cancel, and we're left with moles of water. And what is this on our calculator? 200 divided by 18.3. 11.093. I'll add some extra digits. Okay, 11.093 moles of water, which is our solvent. Right, let's do our moles of solute now, which is sucrose, right? 10 grams of sucrose. Sucrose is C12H22O11. So we have 10 grams of C22H22O11. We have 10 grams of that. And let's go ahead and convert it to moles using the molecular weight given to us in the problem. Okay, 1 mole of C12H22O11 is how many grams? Alright, so carbon is about 12.01. And then we have 12 of those units. Hydrogen is about 1.01. And then we have 22 of those units. Plus oxygen is 16.01. And then we have 11 of those units. So we're getting about 342.45 grams. All right. So the grams cancel. So what's 10 divided by 342.25? Okay, 10 divided by 342.45. 0.0292 moles. Okay, I'm just adding some extra digits to carry over. Okay. So now let's calculate our mole fraction. Okay, since this is mole fraction of solvent, solvent goes in the numerator, mole fraction. Okay, that X means mole fraction. Okay, in any type of fraction, the denominator will have the whole thing, solute and solvent. So we have moles of solute and moles of solvent. Let's do the moles of solvent first. This is going to be 11.093 moles of water divided by 11.093 moles plus 0.0292 moles. So what is this on our calculator? Okay, 11.093 divided by 11.093 plus 0.0292. 0.9974. Okay, 0.9974. Yeah, okay, 0.9974. All right. So that is the mole fraction. So let's utilize this equation here. P of the solution, the vapor pressure of the new solution, is the mole fraction of the solvent, 0.9974, times neat, or solvent by itself, which is 23.76 millimeters of mercury. Okay, remember, this is from the equation. Okay. And this should give us the answer. 0.9974 times 23.76. Uh, 23.6, we'll do 23.70 millimeters of mercury. This is our answer. Okay, so it went down from 23.76 to 23.70. It's kind of a small drop, but it's a drop anyways, because remember, the vapor pressure, must lower anytime you add a solute into a solvent and it dissolves. So this is a type of problem that's on the exam. It's the same type of problem, just different numbers. Okay, so if you can do this type of problem on the test, I think you should be okay. All right, any questions or comments here? All right, so this on the exam as your calculation. Another calculation is this equation here. Okay, this involves calculating the new vapor pressure, okay, at a different temperature. All right, so remember, vapor pressure is a pressure exerted by a vapor, and it's temperature dependent. So for this one here, diethyl ether, it has a molar enthalpy of vaporization. We call that delta H vaporization. Is 26.0 kilojoules per mole. Normal boiling point is 34.6 degrees. Normal means 1 atmosphere. Okay, that's something you should know. Okay, normal means 1 atmosphere. So it boils. Normal boiling point means 1 atmosphere, and the temperature of that boiling point for this ether is 34.6 degrees C. So this is the temperature at which it boils. Okay, what is the vapor pressure of diethyl ether at 65 degrees, not room temperature? It's not room temperature, so you can cross that out. 65 degrees. So we have here at P1, 1 atmosphere, which is the same thing as normal. That vapor pressure exists at a temperature of 34.6 degrees C. We'll call that T1 and P1. And then they want the P2 at a new temperature, which is 65.0 degrees C. Okay, so this is what we are tasked to find. This is what we need to find. Okay, so usually the vapor pressure goes up as your temperature goes up. Okay, why is that? Because as the temperature goes up, you have more, vapor. Okay, you break more intermolecular forces, and then you have more vapor, hence more vapor pressure. So we expect this vapor pressure to be higher. Okay? So we're going to use this equation. This equation will be given on the test, so you do not have to memorize it. And the first thing we want to do when you see this problem on the exam is you want to convert the delta H vaporization to joules per mole. The reason why you want to convert it to joules per mole is because the constant R is in joules per mole Kelvin. Okay, so that conversion makes it 26,000 joules per mole. Okay, so delta H evap, or delta H vaporization, is and then we want to convert the temperatures to Kelvin, so T1 is going to be, how do you convert that to Kelvin? At 273. So 307.6. Okay, let's do T2 in red ink. Okay, what will T2 be? At 273, right? 338 Kelvin. So let's go ahead and solve for this. Okay, we want to convert it to Kelvin because Kelvin is in R. Kelvin is in the units of R. Right, so we'll do natural log. P1 is 1 atmosphere. P2 is what we're trying to solve for. Equals delta H vaporization is 26,000 joules over a mole. Okay, I'll give you this equation and I'll give you R, but R is this value here. Correct, very good. 8.314 joules over a mole Kelvin. I'll give you that on the test, so you don't remember. I'll give you this on the exam. Okay, times 1 over T2, which is going to be 1 over temperature at T2, which is 338 Kelvin. Okay, minus 1 over T1, which is 307.6 Kelvin. Okay. Okay, we don't put units inside the natural log. Okay. All right, so does everybody know how to do this on our calculator? All right, let's quickly do this on our calculator together. So first, I would do this. There's many ways to do it. I'll show you how I would do it. But whatever you do, just make sure you know how to do it on your calculator, however you want to do it. So I'll do this fraction first. 1 over 338. Okay, minus 1 over 307.6. Is equal to that messy number times 26,000 joules is that number, and we will divide it by 8.314. Divide by 8.314, and we're going to get minus 0.9144. Okay, I'm adding some extra digits here. Minus 0.9144. Four. Okay, so this is going to equal to natural log 1 over P2. All right, so the next step on here is how do we get P2? Okay, we're going to take the inverse natural log. Okay, the inverse natural log. So what is the inverse natural log? E. That's right, E. Okay, so on our calculator, whatever calculator you have, we will take the inverse natural log of both sides, which is inverse natural log of both sides of the equation. Okay, so E to the power of natural log 1 over P2 is going to equal E to the power of minus 0.91440. Okay, so e to the power of natural log of 1 over p2 is 1 over p2 because they are inverses of each other. Okay, we're solving for p2. And what is e to the power of this number? Okay, so on your calculator, you'll do inverse natural log. So for me, it's going to be the second number and then the natural log key. Okay? Every calculator will be different. Once again, you take the second and natural log. That's e. Okay? E to the power of minus 0.91440. 0.400 or 0.4008. Okay, everyone getting that? Okay, e to the power of negative 0.9144 is 0.4008. Okay, I'm adding some extra digits here. All right, so we will solve for P2 here. Okay, 1 divided by 0.4008. Okay, don't forget the units. I'll take off half a point if there's no units. And 1 over that number is 2.50 atmospheres, 2.50 ATM. So this is the answer I am getting. Okay, so you raise the temperature, there's more vapor pressure because, more molecules become a vapor. Okay, the molecule here is ether, functional group ether. All right, can we do this on the test? Okay, similar problem. Maybe I'll change the numbers. All right, any questions or comments here?
With some of these math problems, are you picky about sig figures or?
That's a good question. I would be upset if you write everything, every digit.
Oh, yeah.
So that would be like, students have done that. I would just go with 2 decimal places if I'm not on the sig figs. If I'm not picky on sig figs, yeah, 2 decimal places should be more than enough. And units. Royce, I'm big on the units. And I'm also big on not writing just because it's on your calculator screen. You write every digit. So 2 decimal places should be fine. Here you can even go to 1 decimal place, I suppose, because this is reported to 1 decimal place, this one, but 1 or 2 decimal places is fine. Make sure you put your units. Okay, that's definite. All right, so similar problem like this on the test. Okay, just different numbers. All right, let's move on here. All right, boiling point elevation and freezing point depression. So similar to what you saw in that video Monday because I wasn't here. So let's say you have some water. Okay, what's the boiling point of water? 100 degrees C. What's the freezing point? Okay, 0 degrees C, degree C. Okay, hold on 1 second here. Uh-oh, what happened? Okay, sorry about that. It's a very old machine here. All right, the boiling point of water is 100 degrees C. The freezing point is 0 degrees C. Okay, we'll take that same water, but this time in this problem, It's saying, what is the new freezing point and boiling point of an aqueous solution containing 4.5 grams of glucose? So here we're going to add 4.5 grams of glucose. And the question for us here is, what is the new boiling point? And what is the new freezing point? What do you expect the boiling point to be? As a colligative property, the new boiling point would be higher or lower? Higher. What would the new freezing point be? Lower. Okay. So what is our solute and solvent? What's our solute? Okay, very good. Okay, and excuse me, 99% of the time in Gen Chem, at least in my Gen Chem class, the solvent is going to be water. Okay, aqueous means the solvent is water. Right, so these are the equations on the test. So this lowercase m stands for molality. Right, can anyone tell me what molality is? Should know this. Molality, what is molality? Moles of solute. Okay, good. But what's in the denominator? Kilograms of solvent. Okay, very good. Solvent is water in this problem, yes. Okay, so this is the molality that goes in here. All right, Kf is a constant. Okay, so I think they tell us the constant. Yeah, so the Kf, the freezing point depression constant as water, with water as the solvent is 1.86. So let's go ahead and do that. Delta Tf is Kf, which is 1.86 degrees C over molal, times molality. Okay, let's go ahead and quickly calculate that. Moles of solute, which is glucose. So we're going to take our 4.5 grams of glucose. Okay, 1 mole of glucose is how many grams of glucose? Carbon is about 12.1, but we have 12.01, but we have 6 of those. Plus hydrogen is 1.01, and we have 12 of those. Plus oxygen is 16.01, and we have 6 of those. So that's about 180.24 grams. So what is this on our calculator for our moles of solute, which is glucose? That's correct. This is what's 4.5 divided by 180.24. 0.0250, I'll go with 0.0250 moles of C6H12O6. Okay. And kilograms of solvent is molal. So what is our kilograms of solvent? Okay, so the back of the hand number for the density of water, backhand density is about 1 gram per mil. So 150 mils of water is about, so we're having 150 mLs. So back of the hand, this is about 150 grams. And how many kilograms is that? 1, 2, 3, about 0.150 kilograms. Okay, so this will be our kilograms of solvent. So let's calculate the molality here for each of these. Moles of solute is going to be 0.0250. Kilogram of solvent is 0.150 kilograms. And what is this on our calculator? 0.0250 divided by 0.150. 0.167? Is that what you guys are getting? Lowercase m. Lowercase m. Right? So this is our m that we see here. Okay. All right, let's first calculate the freezing point depression. 0.167 m. Okay, the molal and molal cancel. So 1.86 times 0.167. What do you guys see here? 1.86. It's about 0.31 degrees, 0.31 degrees. So this is not the answer. Okay, you do not put this as the answer on your test. Okay, what is the answer? Okay, what's the new freezing point? So it's going to be the 0 degrees minus 0.31. So the new freezing point of water is about minus 3.1 degrees C. Yes? So that's the new freezing point. This is the answer you want to put on the test.
Wait, why did you go from 0.31 to minus 3.1?
Oh, it should be minus 0.31, right? Yeah, okay. 0 minus 0.31 degrees C equals minus 0.31 degrees C. All right, thank you. I did that error on purpose. I just wanted to see if you would catch it. Minus 0.31 degrees. So it goes down from 0 degrees to negative 0.31 degrees. Thank you, Grace. All right, let's quickly calculate our boiling point. Okay, everyone see this? Okay, our boiling point is going to be delta TF, the change in boiling point. For this one, it's going to be 0.52 degrees C over M. And it's the same 0.167 is our molal concentration, molality. Okay, molal cancel. So 0.52 times 0.167, what do we get here? Um, 0.086, 0.087 degrees. Okay, this is not our answer. Okay, what will our new answer be? Or what will our new boiling point be? So what will we do? We will add it. Okay, boiling point elevation. So it's 100 degrees plus 0.087 degrees. So this is about 100.08. We'll go with we'll round it to 100.1 degrees. So this is the answer. So it goes up by 100.08. 100.08. So I kind of rounded it to 100.1. Okay. All right. So something like this on the exam, just with different numbers. All right. So make sure you know how to do that.
So once we figure out the M, the small m,
Molality.
the molality, then we only have to figure it out once for the freezing.
Yes.
Okay.
Yeah, and these constants will be given.
Okay.
But one thing you should know, Royce, freezing point, you're going to subtract it. And boiling point, what will you do? Add it. And the solvent is water. If the solvent is something else, okay, you don't just subtract from 0 or add 100. I only did that because of it's water. The solvent is something else. You know, you add here and subtract there, whatever the boiling point and freezing point is. All right. All right, so a question like this on the test here. Let's do one more. All right, here it says concentrated acetic acid contains approximately 96% by mass acetic acid. Okay. The density of acetic acid is 1.05 grams per mil. And what is the molality? So as we mentioned before, molality is moles of solute, or kilograms of solvent. Okay, but the acetic acid has a mass percent. Okay, a mass percent of 96%. This is also called glacial acetic acid. You may have heard of the term glacial acetic acid. All right, so what does the 96% by mass mean? The solvent is water. So this means 96 grams of acetic acid divided by 96 grams of acetic acid plus how much water? About 4 grams of water. Okay, we use distilled water in our chemistry labs. Okay, so this essentially means the 96% that is in the problem. So we were to deconvolute or split up the 96%. It really means 96 grams divided by the total 96 grams plus 4 grams of water. Okay, and multiplied by 100, you get 96%. So what is our solvent? Our solvent will be water. And let's go ahead and convert that to kilograms. Okay, how many kilograms of solvent will this be? Okay, we will move the decimal place 3 to the left. And this is going to be, 0.0. Right, 0.004, which is the same thing as 4 grams. All right, so this is our kilograms of solvent. All right, let's figure out the moles of solute here. And this is 96 grams of acetic acid times 1 mole of acetic acid contains how many grams? Okay, let's quickly do a rough calculation. Carbon is about 12.01. Okay, there's one of them. There is hydrogen plus 1.01, but there's 3 of them here. Okay, we got another carbon at 12.01. Okay, we got 2 oxygens. 1 oxygen and 1 oxygen gives us 2. So that's at 16.01. And then we got another hydrogen there. I think my calculator has officially died. Okay. Midstream. Okay. I think it's about 60 grams. Let's do this really quickly here. Yeah, I think it's about 60. So it's about 60.0, we'll do 60.01 grams. All right, so what's 96 divided by 60.01? 1.600 moles. Okay. This calculator looks like it's also on its last legs. Can you see that? 1.600 moles. Okay, so this is our moles of solute. This is our kilograms of solvent. Is this? And I think this is pretty straightforward. I think the answer will be take this 1.600 moles of acetic acid divided by 0.004 kilograms. And this will be our final answer, moles of solute over kilograms of solvent. 1.6 divided by 0.004, meaning about 400 molal. 400 molal. Okay. That's the same thing as 96% by mass acetic acid. 400 molal. Okay. That's some very concentrated acetic acid. All right, any questions on this? All right, questions or comments here?
The mole fraction doesn't have a unit, correct? Or
It does not have a unit
Okay.
because it's, yeah, the moles cancel. Any fraction will not have a unit. Not just mole fraction, but any fraction will not have a unit. All right, let's quickly go over some of these short answer things here. All right, so I think we've got over this several times, so make sure on the exam you know what molarity is. So what is molarity? Moles of what over what? Moles of solute over liters of solution. Very good. This is called molar. Okay, it's a type of concentration. What about molal? Molality? Excellent. Moles of solute over kilograms of solvent. Okay, so we know that a solution is two parts. As long as it dissolves, it's the solute plus solvent. Right, what about the four main colligative properties? We started off the class talking about it. The boiling point goes up. The freezing point goes down. The vapor pressure, what happens to that? Goes down. And then what happens if you have a semi-permeable membrane? Okay, osmotic pressure. So Monday's video that you watched, I gave you extra credit, has an osmotic pressure problem that we did together. This is pi equals MRT. Okay, what about the three properties of a liquid? Okay, all liquids have this. They will have a surface tension. Okay, what will they have? They'll have a surface tension. Okay, what else will they have? They can have adhesion or cohesion. Okay, this is attraction with the glass or attraction with each other. And what's the other one? Okay, viscosity, viscousness. Okay. Usually something that's very viscous will have a lot of OH bonds, or OH functional group. So if you were to figure out which is the most viscous, you're looking for a lot of hydroxyl groups, because hydroxyl groups can provide a lot of hydrogen bonding. Okay, so more OH, more viscous. Okay, and this is because of hydrogen bonding potential. So some short answer for the exam. We'll go over this on Monday if you want to get a head start. I'll post a video on Friday completing the test review so that you'll know what to expect in terms of short answer and multiple choice. And once again, I will not be here on Friday. I have to go on a flight. And make sure you upload your homeworks, check your answers, and then turn in your homework. And yeah. There's that software, interactive tutor if you want, and also you can go to the tutoring center. Our test will be Wednesday.